So there's just three phrases or three sentences really, yeah. Equations, sentences on the board. Idea for our warm-up, at least to start today, is get you to just write the equation. If you could write the equation, I bet you can solve it. They don't end up being particularly complicated forms of equations. So yes, that's the challenge. Can you write the equation? Let me get, let's keep letting people in here. Yeah, I was thinking maybe I should take my allergy pills this morning. I have a little more congestion than I'm used to. Chest. So here, see if you can make some sense out of that based on what we did yesterday. For that is, I think they're all exactly that same shape, is that, there's your equal sign. So it's really a matter of coming up with the math translation for the first half of the sentence. What's the relationship that's being described? So I can see heads down working, so that's kind of a good gauge for me. Are you guys still working or not? Ladies and gentlemen, guys. I use that generically. We're supposed to try to avoid that, You're not all guys. I try to say folks. All right, you folks. Old cultural habit, I think. Well, without taking too long, right? Where's my, oh good, it's in my pocket. How about, what are we looking for? Well, I didn't say what we were looking for. Hopefully that makes sense. We would be looking for the number. Define a variable. I'm going to use X for all of mine here, all right? 3 times a number. So 5 less than 3 times a number. 2 different parts right there. 3 times a number, the unknown, 3x. 5 less than that quantity means you have to write that other quantity first and then subtract the 5 from it. So 3x minus 5 is 19. That went okay. Do I need to wait longer for you guys? Anybody want to speak up, or are you good?
I finished the first 2. I'm just waiting for you to help me on the third one. So.
Okay. The difference between, now when it's phrased this way, this is going to be a subtraction problem. The difference between now 2 quantities does mean the first number minus the second number. Between 15 and 3 times an unknown value, right? The difference between 15 and 3 times a number, just like the one above it, right, is 17. So that's worth, didn't plan it that way, but kind of good to see the different phrasing for 2 different subtraction situations.
I have a question.
Yes.
So my open math didn't let me write it like that. They had me write it, so the correct answer, so for the first one, it would have been 3 times with the like symbol in it, and then x, and then minus 5 equals 19. They wouldn't let me write it 3x minus 5.
In mom, huh?
Yeah.
Well, I'm going to poke around at that again myself a little later.
Because I tried to do it last night, and I did everything like that. I wrote it like that, but it said it was incorrect. And when it gave me the right answer, it like had me do like actually put the like multiplication sign in it.
That's that seems, I want to say redundant or something, like asking you to do more than is necessary. I have to explore that a little bit, okay? So I'm
Okay.
sorry that shouldn't be necessary in my mind. But there are quirks in the program. I don't know what to tell you exactly, but now that you know that, I guess suppose now you got to put in that the asterisk. Is that what you were using? The asterisk.
Yeah.
Yeah. Okay. Well, folks, if you heard that, just keep your eye out for that. Okay. This last one positive number. So this is a way of saying, comparing them already. We know that they're all positive. One number, okay, one positive number. I don't know what that one is. I might call it an X. There's one positive number. One of them, is 5 times another. Oh, maybe, okay, so here's the other one. All right, here's some unknown value. And this first one that they're describing is 5 times another one that I don't know. So here's a way to describe 2 different numbers in terms of one of them, and only have to use one variable. I better let this person in.
Okay, so you can only use one variable if you want to.
Yes. Our very last chapter, actually, we're going to see some of these same equation shapes or problem shapes, and we're actually going to start out by saying, okay, here's one number I don't know called X, and one number I don't know, it's called Y, but they told me Y is built out of X. So we're actually going to start with 2 variables, but get rid of one of them because we don't know how to do anything with 2 variables. We have to always do it in terms of one variable. Somehow we have to be able to compare them to each other with one variable. That's what we're doing at this point. Their difference, because they're positive numbers, 5 times is going to be the bigger one. So I can say their difference is this whatever number. So this, yeah, that's why I put that one up there at this point, really to say, yes, here we have a way of describing 2 different values, but one of them in terms of the other. There are several of them, I think, along those lines in your homework. It's kind of like yesterday's example of Paul and Philip, right? Philip made so much more or something than Paul. So based on Paul, Philip made, we had to use Paul's variable or something like that. Okay, well, so good. We had a question there. Maybe hopefully worked something out there. Any issues with that for anybody else? All right, then I'm going to erase. Here we go. Talk about a couple other shapes that we're going to run into. We're practicing this translation, writing equations, right? This next one in particular, you know what, if this makes sense to you here, I'm going to give myself a little more room, okay? Hopefully you've got that in your notes. I can talk it through. This next form I want to describe is one we're actually going to see quite a bit in chapter 4. It'll be a slightly different context than we can work with right now. The idea is that we have some final value, you might say. Over here, I'm going to call it total. Or often it's deals with money, or maybe it's a total number of items or something like that. The total is a result of 2 different values that are put together. One of those values is usually some fixed amount. And I'll give some hopefully kind of obvious examples. Fixed amount, and then it's combined with some variable amount. An amount that changes depends on the variable. All right, so this is going to be the term that has our variable in it, and there's usually some other number that's always it's always the same, but then this one changes, depends on time or quantity or something else. Let's see, like, well, before the advent of cell phones and unlimited call plans, when you would have to buy an extra long distance, a separate long distance plan to go with your home phone system. And so you might have to pay say a fixed amount of $25 per month for this long distance plan, plus, oh, let's say it was usually something like 5 cents per minute. And that's how you figured out what your total phone bill, long distance phone bill would be for the month, right? Just to have the plan, I have to pay $25, and then for every minute I'm on the phone, I pay 5 more cents or something like that. Or a car rental, right? Car rental, again, often money, easy to frame here. Car rental, I'm going to rent a vehicle, and this big truck, they want charge me $50 plus $1 per mile, right? So there's where the variable goes. $1 for every mile. There's my variable amount, and so my total depends on how many miles I drove, right? Something like that. A company might have, say, weekly, $500 in overhead, and then manufacturing costs of $5 per item that they make determines what their expenses for the week might be. So this shape is actually comparing two different values. The total is a result of this how many you use, or this variable amount. Now for our situation, in next chapter, we're going to see this could change to an infinite number of possibilities depending on how many minutes, right? 1 minute's going to be one price, 5 minutes could be another price. And so this is the kind of situation next chapter where we start getting these graphs. 1 minute gives me this amount, 2 minutes gives me this amount, 3 minutes, next chapter, don't worry. But right now we're going to say, oh, here's my situation that the problem describes, and then it'll say something like, well, if your phone bill was $50 for the month, right? If your phone bill was $50, how many minutes did you use? So now we're solving for our variable. We have to be told at this point what the value, the total is. And so when we read our problems, we have to pull out this information. Some fixed quantity, an amount that varies per item, adds up to a total. Here you can hopefully see, and it could be the other way around, right? You might choose to say 50 equals this plus this, right? Here you can see I would subtract the 25 and then divide by 0.05 to figure out how many minutes I must have used, all right? Here I could say, oh, what was my example here? I forget, oh, this was car rental or truck rental, right? If I spend $150, how far did I go, right? How far did I drive that truck? Well, let's see, I'm going to subtract the 50 and then divide by 1 to say, oh, I must have gone 100 miles. But again, we have to be given the variable amount, a fixed amount. We have to be given the total. And similarly here for some overhead, if the company, spent $1,500 that week, how many items did they make? Something like that. Okay. Another application or use of this sort of mold, this model, population sometimes. And let's see. Currently, the returning overwinter monarch population is down to about 150 monarchs in the valley, but it seems to be decreasing about 20 monarchs per year. I'm making up some vaguely realistic situation. Fixed amount, we're starting at this amount right now, but we're going down 20 per year, minus 20 per year, right? Minus 20 if it's decreasing. A population problem, sometimes the population is going down a certain amount. How long will it take for the annual returning population to get down to just 50? Oh, here I'm going to subtract, which gets me a negative 100, right? I'm going to divide by negative. So I think I just made up numbers. That's in 5 years, we'll be down to even less, something like that. But population kind of example. Now, this really is, I'm looking at your homework, and I think like questions like 5 through 8 or something like that are really just like this. And some of them have some bigger numbers or decimal values. You get to use your calculator, of course, which I hope makes those kind of easier to deal with. Does that, I wonder if that's a good enough explanation for this kind of this form right now. Like for, you know, you might, please, let's see if we can leave it at that. And as you work through, like I say in your homework for this section, 3.1, we're still talking about, I think just looking here, it's like questions 5, 6, 7 are this kind of setup. They're gonna somehow give you a total, a fixed amount, and then it changes. And that's where you're gonna put your variable. Okay? That's right, get congestion moving. The last group that you're running into, they're kind of, oh, pardon? Question? No, okay. The last groups that you're running into, kinds of questions, let's see, tend to be based on, well, they're consecutive number problems, right? Got a bunch of numbers in a row and they add up to something like that. So, gee, just thinking that through, they're saying I've got several numbers in a row, and this is, well, you know, and find the numbers. Well, I can only use one variable. I can't say x plus y plus z, right? Well, let's say this is the first number, or a lot of times I use n for number, right? If this is the first number, how would I describe the next consecutive number, the one that comes after it? So one more than that, right? So the one that comes after that is x plus 1. Well, what if I have 3 in a row? What's the one after that? Well, it's 2 more than that first one. So here are consecutive integers or consecutive positive numbers. And these kinds of problems will say something like, the sum of these 3 consecutive integers is, you know, whatever, 73. So there I would add these 3 expressions I've just built. First number, second number, third number. And so now really I have 3 x's, right? That's not going to work out evenly. I should have made that a better number over there. I can just do the mental math and see how about 72 will work out better. Okay, I can see that. But 3 x's plus 3, subtract the 3, and then I have to divide. But you could figure out what the first one is, and then from that, figure out the other ones. Similar kinds of problems. Consecutive something or other, right? How about consecutive odd integers? Consecutive odd numbers. Well, okay, I've got several of them in a row. Here's the first one, say it's a 3. The next odd one's 5. How much more was that, right? Odd or even, you have to jump by 2s is what I was getting at. So the next one would be x plus 2. The next odd one would be 2 more than that. And so on. I think one of them actually says you got 5 numbers in a row, something like that. And then they have to tell you it adds up to something. And so then you can figure out what each one of them must have been. Okay, does that work for you? I think that gets you through the last 3 or 4 kinds of word problems in our first section here. And if that's good enough for now, you will give those a try. Get back to me if you're really stuck on something, or use whatever other help you get. And send me messages if you have questions. But I'm going to change gears now and start our 3.2. All right. Percent-based equations. If you were in Math 20, pretty sure if I recall, you do some percent problems. We were going to start with what you might recall as some, what we kind of call a basic percent shapes. And again, hopefully kind of a nice way to be able to translate from a sentence, a word problem, and then to translate to an equation and of course solve it and find the missing values. And then we'll move into a couple different, I guess I have to say, slightly more complicated, like two-step percent problems where I got to figure out something first before I can do it. So first of all, what's a percent, right? Parts of 100. It's a sort of notational shortcut, kind of like decimals, right? Parts of 100, if I can imagine a quantity that I could divide up into 100 equal pieces, how many of those 100 pieces do I have? That's what percent stands for. So, you know, 15% is 15 parts of 100. Really the fraction 15 over 100. 15 pieces out of 100. That's what that notation stands for, right? So from that argument, I'd say a presentation, I can pretty easily, I want to easily be able to change percent to the decimal value. When we use it in an equation, we never actually use the percent version in an equation. We have to convert it to its corresponding decimal value. So 15 over 100, I try to be careful and write the 0 in front. We like to see the placeholder anyway, but there would be the decimal equivalent. It's always basically, you know, from the percent, you're moving it over 2 places. Right? Moving it over 2. Or how about something like that, 35.5%. We are still just moving the decimal 2 places left to convert it.
So technically, as long as we're looking at a fraction, we can turn it into a decimal. And as long as we know how to work with decimals, we can do this math.
Yeah, I won't take too long, I guess. Maybe that's what it sounds like, but.
Well, no, that's just me. I'm just now getting comfortable with decimals. So don't rush ahead or anything. I'm just recognizing what you're doing.
Okay, all right. I'm sorry. I won't rush. Don't worry. So again, right, I could write this as 35.5 over 100. Now we don't like to mix decimals inside of fractions. So here I would multiply top and bottom by 10 to get 355 over 1,000, which is what that decimal means, all right? And yes, I could, if I got this far, I wasn't sure, well, you could plug in the calculator. One to watch out for is when there is only like what do I want to say, a single number percent, like 7%. What's the decimal? I still have to move it over 2 places. 7/100ths, that means, right? 7 over 100. Or 2 places means I have to put in a placeholder 0. Right? 0.7. 0.07. Say it correctly, Steve. So watch out for those, what do you want to say, single digit percent values converting to a decimal. Put in that extra 0 there. Now going the other way, right? If I have, I did decimal to, I did percents to decimals. If I have decimal values, you know, 0.67, what's that equivalent to as a percent? Well, move it 2 places to the right. (67/100ths), right? Or even if it was, if there are more decimal places than 2, you're still only going to move it over 2 places, and so my percent's going to have a decimal in it. All right. Haven't done one of these yet, but what if we're talking about something greater than 1, right? 3.5. I'm still going to move it over 2 places, right? 350%. Or how about one of these over here if I had what, 125%, what's the decimal equivalent of 125%? Anytime you get over 100, it means you've got 1 point something, or you got more than 1, right? So, 1.25, right? 1.25. Mix myself up, get back and forth here. So that's just basics of, converting back and forth decimals to percent. All right. Just want to address rounding again for a second. I think it was hand-in homework in particular. Maybe it was even a couple test questions where it said round to the nearest tenth. Some of you showed me too many decimal places and you lost a point, just 1 point out of the total. Or some of you rounded, that's a different issue, but some of you rounded early in a problem which ended up with a slightly different answer. And I think I didn't mark it down, but I tried to point that out in a comment that I would make about your work. And see if I can just point that out. But just be careful here. Let's say I've got 1.375 and let's see, how do I want to point this out? Well, I'm going to say, what if I had this number and I'm supposed to round? If you'll allow me, right? Okay, I'm going to just make it a 0, not over 100%. Round the corresponding percent to the nearest whole percent. This is a decimal value, and this part was saying, once you turn it into a percent, then round the percent value to a whole number. Don't try to round the decimal early, right? That'd be like 0, right? If I rounded the whole number, it'd be 0. Turn it into the percent and then do the rounding is what I'm getting at. So this would be 37.5%. And if I'm rounding that percent to the nearest whole percent, right, I want to stop here, look at that number to the right. Is it supposed to go up or down? 5 or up goes up. So this is approximately 38%. If I was following this instruction to round that percent to a whole number. So I just like to point out that possible issue. Don't round until after you make the change to the format that you need to leave your answer in. That other issue I was just talking about, rounding in the middle or early in a problem. This is kind of a side topic. All right. I think it might have been the one with the circles and 2 little circles inside or something, and then you were supposed to round your answer to 1 decimal. And if I seem to recall, those smaller circles had some area of something like 12.56, blah, blah, blah. And some folks rounded that like right there. They rounded it and got 12.6. And so when there was 2 of them, right? There was 2 of them. So you had to multiply that by 2. And 2 of those turned into what? 25.2. Something, I hope my example is going to work out right. But if I had done 2 of these, it was something like 25. Oh, it's still not going to work right. I'm sorry, but something like this, 25.113. Yeah, my example's not working out right. See if I can just make the point that if you're supposed to round your final answer, try to use as many, at least a decimal or a place or 2 more than your final requirement in the middle of a problem. Don't round every number all the way through the problem. You introduce what's called rounding error. You've rounded all the pieces, and so your final answer is probably, could often be off a little bit. Try to wait. Oh, she's not waiting too long. Try to wait and use as many decimals as possible, especially if you're using your calculator. It'll just keep saving them all up in there. Round at the final step. That's all I was trying to get at. See if you can hold off till the final step to do that rounding. All right, a lot of talk there. That's three basic types. Get my notes here, right? Here's an example. There are, in these basic percent shapes, there are three quantities. What number, oh, there's our variable, right? We're going to use that translation that we've been trying to practice already. And that'll be our equal sign. Here's our unknown. Of always means multiply. 15% of 80. Change to decimal. We never use the percent in the equation. Change that to decimal. And sorry, you have to use a little star in mom. I think that's annoying. I'm going to go back and look. So 0.15 times 80. The number we're looking for is 1500ths of 80. So here's a translation, right? One number is 0.15 times 80. Three different quantities, right? The final value, the percent, and you might say the starting value, something like that. So here's one type. Oh, see if I got decent. 110 is what percent of 88? What percent? Oh, this time we're actually looking for the percent number is the unknown. Now, just because it's different, it's the percent. I usually write it as P when I write my equations. I just like to show that, remind myself that was the percent. So, 110 is what percent of 88? Again, there's our translation directly from the sentence. If it's in that nice shape, if I can put it in that nice sentence, simple sentence shape, I can translate it easily. Here you can see, now I would divide that by 88. I'm going to get something greater than 1, right? So it's going to be something like 1 point blah, 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 blah. I always have to take that decimal in this kind of problem and turn it into a percent. Right, got to turn that answer into a percent. If you're looking for a percent, you're going to get a decimal and you have to turn it into a percent. And I'm going to erase this first one so I have room, or I'm going to go up here, okay? Here I go. Here's the third type. Huh? Excuse me. It's supposed to be 3.06. You see that? Yeah, okay. Here's this third type. What are the three different types, right? There are three different numbers, so I can have three different missing values. Right? 8.5% of what number is, there's our equal sign, right? 8.5%, turn it into a decimal. 2 places. Here's one of those where I need the extra 0 placeholder. 0.85 times our unknown. So 8.5% of something is 3.06. What I'm trying to point out is this translation is not too difficult if that makes sense. I try to avoid saying easy, but if it's in that kind of simple sentence shape, you can translate it pretty directly. Okay, so 3 different possibilities for the unknown value. Which part of the basic 3-number equation are you looking for? I wasn't going to plan to actually solve these at this point, but could you see here I would divide by that number and figure out that, divide by the 0.085, and that would get me my x. Huh? Hope that's okay. Once you get to the equations, they tend not to be real complicated shapes. Let's see. A bill for $81.50 at a decent restaurant. How much is 18% tip? Okay. Now, here's already a story I'm kind of making up. I wrote it as 2 sentences. Can I rephrase it as that single sentence? How much is 18% of 81.50? There it is as one sentence that I now hopefully can translate into the corresponding equation. How much is what I'm looking for, right? How much is 18%? Convert to decimal. 81.50. This shape's always kind of nice because, gee, the variable's already a loan over here. All I got to do is the calculation, stick that in there, right? My mental math tells me that's going to be about $16. How did he do that? You may, if you do much tipping, I always kind of double this number. That'd be 20%. If you know what I'm saying, like 2 times 8 is 16. 16 would be 20% of this value. So it's going to be a little less than, I can sort of tell am I in the ballpark, right? 18% ought to be a little less than 16. I should get my calculator right here. I could actually figure that out. But that's a nice little mental math trick, right? If you're in a restaurant, 20%, double it, and then move the decimal place. Double would be 162. 160, and then move it over, get 16. If you want to do a little less, round it to the nice whole dollar value or something, whatever you do. 0.18 times 81.5. I got 14.67. If I was actually in a restaurant, I'd probably round it to 15 or something like that. You know how that works.
I got the same thing.
Good, good, good. Thank you. That's always good to know somebody else is agreeing. All right. So if it's not entirely straightforward to begin with, if you can rephrase it, we tried to do the same thing on yesterday's word problems. If you can rephrase it in a single sentence, that's often easier to translate. How am I doing time here? Okay. And how about cereal serving has 7 grams of fiber, which is 28% of, what is it, recommended daily value. What is the recommended daily value? You allow me that abbreviation there. Of so, can I write this as this sort of single sentence? 7 grams is 28% of recommended daily value, right? That's our unknown. can get it to that, I can write a sentence, write equation. 7 is 0.28 of what I'm looking for, 28% of what I'm looking for. How much fiber am I supposed to have? Folks of a certain age start talking about fiber. All right, so how would I solve that? Hopefully that's pretty obvious here. Divide by that 0.28, which our calculate facilitates very nicely. And so 7. 25? 25 grams per day is what you're supposed to have. That's apparently. So not always going to get the simplest sentence, but hopefully you can take the information and rephrase it, at least in your own mind. Write that more simple sentence and then translate it. Same kind of question, I'm going to ask you to do it. Sodium, right? Gotta watch out for too much salt. Only if high blood pressure is an issue. Otherwise, folks don't need to worry about salt too much. 190 milligrams of sodium is 8% of the recommended daily value. What is the recommended daily value? If you don't need that second sentence, simple sentence, fine. Something like that. It's your, combined simple sentence. Move that decimal point over. Anybody got a number to share? Don't look if you're not done. Sorry. I got kind of a big number, all right? Yeah, don't look till you're done. Ha ha. Did you get that?
Okay, that's what I got.
Good, good. All right.
Kind of like this. Kind of like this.
You like this? Is that? These are working. All right. That's good. Always like that. Oh. Out of 230 calories, 60 are from the bad stuff, fat. Now you need some fat. What percent of calories is fat? All right. Depending on some diet or something you might be on, you only want 30% fat or something like that. I forget. Zone diet was one a few years ago. 40, 30, 30. Carbs, protein, fat, something like that mixed. Okay, so out of 30, 60 are. Now, my second sentence is almost the start of the simple sentence I want to make, right? What percent of 230 is 60? Does that make sense? Can you do a guesstimate, an estimate? Compare those two numbers in your head right now. They're sort of a close, nice round number. 60.
Maybe around a quarter.
That's what I'm kind of looking for, right? So if you sense to see that, you know your percent should be something close to 25%, right? A quarter. So what percent? So again, here's where I say, well, I like to remind myself by writing a P for the one I know I have to change back from a decimal into percent. Some percent of 230 is 60. Somebody looks to be at my door. They're delivering. Oh. It's my neighbor.
Is that 2.30 or 230?
Oh, that's 230 total calories. Sorry, I did spread it out too much, didn't I? 230. Some percent of 230 is 60. Now, and then to solve, right, we want P alone. So I divide by that 230. And so do that. We're going to get some decimal value, right? Got to get we're going to get a decimal from that fraction. Fraction to decimal is just a division. 60 divided by 230 is how I convert a fraction to decimal. And I've got 2608, blah, 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 right? And let's say we're going to round this to the nearest whole percent. So here's an example I think I was talking about. Don't round it now. It'd round to 0 for a whole number. Turn it into percent. Right, 26.08, blah, 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 percent. But nearest whole percent, approximately 26%. About a quarter of those calories is fat. Yeah, I think in general that's not terrible. You know, if you can do that, look at some of the things we eat that, oh my gosh, like sausages, hot dogs. Oh, but they're so good sometimes. They're like 3/4 fat. Oh, well, we'll stop with that. I think I basically worked through I'll call them the basic types, the simple types in this section, 3.2. What we want to come back and talk about tomorrow are problems that are called percent change, percent increase or percent decrease. If it changed from this number to this number, what was the percent change? We kind of have to find the difference first and then build our percent equation. So we'll do that kind of thing tomorrow, okay? Another day of these percents. So that's it for our time today. Kind of a good stopping point, lesson-wise. All right, so do your best. Let me know if you have questions.
Thank you, Professor.
You're welcome. Let you go then, okay?
Thank you so much. Everyone
Thank
have a
you.
good day.
You too, yes.
Take care.
Thank you.